So hi there, my name's Harry. I'm the CEO of Phasio, and I'm here with Armin.
Yeah, my name is Arne Bring. I'm CEO of Core Technology. We are a company based in Germany with our development team in France. We are on the market since 25 years, making a 3D software in the CAD area, in interoperability area. And since 5 or 6 years ago, we started with additive manufacturing software for nesting, also texturing, data structure creation. And our goal is to provide a universal software for all 3D printing methods and machines.
And so in this video, we're going to be walking through the end-to-end integration between 4D Additive and Phasio. The goal of this integration is to ensure that from the moment you accept an order to the order management, preparing a build, getting a type packing, sending the build to the machine, and then tracking and ensuring that build is traceable, all of that is encompassed within one workflow. So we're going to go ahead and we're going to share a screen and we're going to walk through the end-to-end of what this could look like, in this case, in a multi-jet fusion facility. So we're going to start by creating a quote here. So we're going to go to create a quote, specify the customer we're sending the parts to, we're sending the quote to, we're going to upload some parts. So while these parts are uploading, there is a manufacturability analysis being executed against them, and we're also identifying whether or not we've seen this part before. This file recognition or part recognition is really important because one of the things that's quite important in the multi-jet fusion process is locking the orientation of the part to ensure that every time it's always manufactured in the same orientation. So as you can see, these parts are identified as being existing in library, and what this is telling us is that we've seen this part before and we have some data on it. We can go ahead, we can attach people to our quote. We see the price that we've got here. And I think on this, we wanted to produce, so we wanted to get 42 of the bracket. We wanted to get 12 of the handle. We wanted to get 4 of the door opener, 8 of the hip joint. What's this, the sprinkler? It's 20. Okay, excellent. Let's send this quote to the customer. So in the background, Phasio is updating all of the accounting system. It's keeping track of the quote across all of the different parts of your order management system, so the accounting system, CRM, and whatnot. And this quote is now in the customer's inbox, meaning that they can go in, they can pay for it, they can send you a purchase order if they want. The quote is outstanding. If we were to receive a purchase order for this quote, then we simply provide the purchase order number here, and this quote will be turned into an order. As soon as the quote is turned into an order, we're going to get a production workflow here. So essentially, everything in Phasio, every order is associated not just with quoting, but also with the production mechanics. And so you can see on every one of these parts, we've assigned a workflow that encompasses downloading the parts, nesting them, sending them to the MJF, and doing quality control. The way we're going to start production on these files is we're going to hit create work order. We're going to allocate them into production. So we're going to go into our planning screen, and we're going to see that these files are sitting here in planning waiting to be produced. But there's one thing we've missed in this so far, which is I mentioned at the beginning about locking the orientation of the files. It's very important on the MJF machine that we always orient the files correctly when they're being manufactured to ensure that we get consistent material properties from the part and that the end customer always gets a consistent surface quality. So what I'm going to do is show you how this works within Phasio. So we go to our part specifications and we'll click on, for example, the door opener. The door opener, as you can see by default, is on its side here. We've actually put a manufacturing constraint onto this file though, which has it standing up. This ensures that the file is always manufactured when it's standing straight up. And this is a constraint that's attached to all of those files that I've just uploaded. So if we take a look at the bracket as well, we'll see a similar manufacturing constraint on that file where it's standing up here. And what we're going to do is we're going to go ahead now, we're going to download the file so that we can begin the nesting process. And then I'm going to hand it over to Armin, who is going to walk through the process of nesting it inside of 4D Additive. To do this, all we're going to do is we're coming into this screen here, and we're hitting the download parts button. We're changing the download format to CamSpec. CamSpec is a format which has been developed, it's an open source format which we've developed and is integrated with both Phasio and also 4D Additive. So I'm going to go ahead and download this. And then I will pass this over to Armin to continue on the 4D Additive side. Okay.
Okay, so once the file has been saved from the Phasio system, we can directly load the CamSpec format. In this CamSpec format, the files are saved as well as their quantity and on which platform machine the manufacturing should take place. So in this case, every machine that is in this list can be specified in a CamSpec file. And there are numerous machines in our database. Once this has been done, you just load the file. You have all the files with the orientation, and this orientation has also been specified in the CAMSPEC file, the quantities. Then you just have to sort it out and hit on pack, and then you can just edit your nesting parameters in order to get the exact packing you want. Now we see the parts being put in the build space of the machine by an automatic nesting process, which also has a lot of possibilities to be configured, because what we are doing here is an optimized nesting, especially for HP machines. It's important to distribute the parts in a manner so the heat distribution is perfect, or there are no heat nests in an area of the build. And after packing, now the packing has been done already. Now the software is optimizing the positioning of each part in order to avoid heat nests, to ensure an optimal heat distribution throughout the whole build in X, Y, and Z directions. And this is what you can see here in the material repetition report. So you try to avoid peaks at the best you can with this nesting. And then at the end, what you do, you can either directly connect to your printer, send the data through a direct integration with HP machines, or what you can do is export a tessellation file. Now there are some models containing errors, and so I'm just running a healing algorithm that automatically creates a perfect closed volume of each model, and then you can output it to a 3MF file, which then can be imported into the Phasio system. One remark for the orientation of parts, the software has a clever way to align parts with a special algorithm that helps you to justify the quality of the part through different orientations. So when we look at this part here and we run the orientation, then you can see in real time where you've got big stair-stepping effects in red. So you would not align a part in this orientation because all the important surfaces now would have a big stair-stepping effect. So now you can really align parts in a way that it has an optimal surface. This helps you to check in the data also in a perfect manner into Phasio systems. So you just keep the orientation, keep the analysis position. So now you can check it into the system. Just as an add-on to the nesting, I think this is also important information here. Okay, Harry, now I can hand back over to you so you can explain what happens now to track production.
So here in Phasio, we're back at the planning screen, and of course, Armin has sent us the 3MF file, which he's just prepared. If we go into the parts in nesting screen and hit the play button here, we can see that our components are sitting here waiting in in parts in nesting. Now, of course, there's a bunch of different parts in here, more than the parts that we initially uploaded. Now, of course, this is always a problem when you're trying to prepare a build, because you don't know, for instance, if you accidentally added too many parts, a couple didn't make it in, or if you added a part that you weren't initially planning to add, it can be difficult to track what actually made it into the build. The way we solve this in Phasio is we have the upload bill of parts function, where you simply select the 3MF file, and it's going to automatically identify the parts which made it into that build, and it's going to pull them over. So essentially what it's doing is it's reading the 3MF file, which is output by 40 Additive, determining which files made it into the build, and then pulling them to the next step, meaning you can never miss a file. You can never accidentally include a file that's not there, because the system is going to tell you if you do that. Okay, so now that we're back at the planning screen, we can see that this new build that we've just prepared, which is build 419, is currently sitting inside of waiting for production. So let's go ahead and start producing these files. So waiting for production, we can see all of the files have to go into MJF together, so we can actually fast forward this build straight into MJF. And when we do so, we're going to see that it immediately pops up at the bottom of the MJF swim lane. Now, of course, in reality, when this build is running, it's going to take time to run. However, to illustrate the point, what we're going to do is we're going to fast forward this again and assume the printer ran straight away, and we're going to forward it into quality control. So build 419 goes into quality control. And what we can see here is that all of these parts have just popped up inside of QC. So let's go into the QC screen now and start testing and start checking these files. Okay, so some of these files are not related to our builds, but let's focus on the ones that are related to our build. So in build 419 here is the build that we're interested in. So let's say that all of the sprinklers look good and all of the hip joints look good. There's let's say there's one door opener where it has elephant skin, for example. We can scrap that here. So we'll say elephant skin, and we can schedule a replacement of one if we'd like to, and that gets scrapped. Let's say also that the bracket, let's say there's 5 of these that were scrapped due to like lack of fusion or something like that. And we'll schedule a replacement for them as well. The rest of these files we're comfortable with, and we can move them over. And those guys progress in a single build through to ready for shipping. Okay, we hit proceed. Excellent. And so now all these parts are sitting here inside of ready for shipping, and the ones that we said we scheduled a replacement for have been pushed back into parts to be downloaded. Now let's go to the orders screen and go check out build 249, which is, you can see the progress indicator has increased to 77%. If I click this and I open up the production screen here, what you can see is that all of these parts have moved through to finished, except for the ones that we scheduled the replacement for, and the ones here that we have still sitting inside of quality control. Let's open up the door opener, for example. And what you can see here is that 4 were scheduled, 4 progressed into nesting, 4 moved into production, 4 moved into MJF, 4 moved into quality control. And then 3 of them moved into ready for shipping, while another one was scrapped because of elephant skin. That one was rescheduled down here, and that's now sitting inside of the production backlog waiting to be moved forward. And we'll see a similar thing on this bracket as well. Of course, we see scrap down at the end, reason lack of fusion, and there's 10 parts that have moved into ready for shipping, and these parts down here are still sitting in the production backlog. So you can kind of see here how you get the end-to-end workflow from the integration between 4D Additive and Phasio. The point here is that we want to ensure that from the moment you send the quote to the customer, you know how you're going to make it, you know any relevant historical information about this part. You can send the part into a nesting software with information exchange back and forth, which eliminates errors and improves the consistency of the build quality for the end users. That's what this is all about. So thanks so much for joining, for taking a look at this video, and we look forward to working with you in the future.